In this video, we're going to be talking about calculating critical values, and this is going to be primarily for hypothesis testing, and we are doing hypothesis testing for one sample means, two sample means, and these means are when we do not know the population standard deviation, so we will be using the student's t-distribution. And we'll also be talking about calculating critical values for proportion problems, one sample proportion and two sample proportions. First, what is a critical value? Your critical value is a z-score that's indicated by alpha. And in hypothesis testing, what it does for us is it indicates at which point do we have strange, weird, or unusual values. We also refer to this as our critical region, our rejection region. Is also called different things in different places, a z-value if you're working with proportion problems, or a t-value if you're working with mean problems. Some places they call it the multiplier number, some places they call it a confidence coefficient. When do we use our critical values? So everything in this chart where it is z sub alpha over 2 only, I have a separate video on that. So when you're creating confidence intervals and you're using z sub alpha for proportions, or when you're calculating sample sizes, that's referring to z sub alpha over 2. All of this information I explain in a different video. Here are the links. If you can't type in this link directly, then you can go under my regular YouTube page under the statistics playlist, Math 1401 statistics playlist. In this video, we're adding on calculating t sub alpha over 2 and your classical or traditional hypothesis testing approach. Here is a summary from one of my documents about how do you perform classical hypothesis testing, or some places they call it the traditional approach. And when you want to find your critical value, the first thing you need to do is to slow down and read the problem. And you need to be able to identify whether this is a mean problem or whether this is a proportion problem. Depending upon whether it's a mean or a proportion, that determines whether you're going to be using the variables of t or whether you're going to be using the variables of z. At the top of this chart, we have the functions you would use if you're a calculator person. At the bottom of the chart, we have the functions you would use if you're a StatCrunch person. If you're taking this course online, then you can only use the TI-83 or 84 calculator. So if you have a proportion problem, calculator people, you're using the function inverse norm. That takes your area to the left. Then it takes a mean of 0 and a standard deviation of 1. So you're working with your standard normal distribution. If you have a mean problem, then the function you're using is inverse t. Inverse t also takes the area to the left, and df. Your df is your degrees of freedom. If you have one sample, your degrees of freedom is your sample size minus 1. If you have two samples, your degrees of freedom, according to our textbook, is the smallest sample size minus 1. So the smallest sample size of your two samples and subtract 1 from that. If you're a StatCrunch person, you're under stat calculators and normal for proportion problems. If it's a mean problem, you're under stat calculators and t. You enter different things in depending upon whether or how you answer this second question. What type tail test do you have? Do you have a left tail test? Do you have a right tail test? Or do you have a two tail test? And the wording in your problem is going to let you know what type tail test you have. If you have a left tail test, that means your value of alpha, your level of significance, is on the left hand side. This means your symbol is going to be negative z sub alpha if it's a proportion problem, or negative t sub alpha if it's a mean problem. If you have a right tail test, that tells you that alpha is on the right hand side, in which case your symbol is going to be positive z sub alpha if it's a proportion problem, or positive t sub alpha if it's a mean problem. If you have a two-tailed test, or if you're doing confidence intervals, that's when you're going to be dealing with z sub alpha over 2, and you see you have a plus or minus sign in front of both of these symbols, z sub alpha over 2 or t sub alpha over 2, because you have two different tails. With confidence intervals, you're only looking at the positive value of the critical value. With confidence intervals, you're only looking at the positive value of your confidence intervals. So if you're a calculator person and you're using TI-83, you always have to have the area to the left. That's your first argument. So if you have a left tail test, that means you're just typing in the value of alpha. If you have a right tail test, you have to calculate the complement of alpha. You have to find 1 minus alpha, and that's going to be what you type into the first blank. If it's a two-tailed test, then alpha is split over the tails. So you have to take your alpha value and divide it by 2, and that's what you're going to enter in for your area on the left. If you're a StatCrunch person, then if it's a left-tailed or a right-tailed problem, you're staying on that standard tab. You're just changing the inequality sign that's associated. You're putting alpha into the probability box, the box at the very end. If you have a two-tailed test, that's when you're switching to the between tab. And then you're entering the complement of alpha into that very last box. So with two-tailed test, your level of confidence is what's inside. I'm 95% confident. I'm 99% confident. Your alpha is what's split on the outside. So you have to enter on the between tab the actual area that's in between, the actual level of confidence. If you don't have inverse T in your calculator, you're going to second and vars. And there is your inverse norm function, and right below that you should have an inverse t. If you don't, you have a couple of different options. You can use a website. So I've included a link to a website here, and you can type in your degrees of freedom. You can type in your alpha into this very last box, and you can pick whether you have a right tail test or a left tail test, and you can use these for your two-tailed test. Your other option is you can create a program in your calculator. Here is the YouTube link that walks you through how to put the program into your calculator. Here is the actual program as a PDF. And how you would use this is you would press program. Once you have it created, you would press enter to make the program start. You would press enter again to make the program begin. You type in what your area on the left is. So once again, if it's a right tail problem, then you use the complement. If it's a two tail problem, you divide alpha by 2. Once you have that value, then you type in your degrees of freedom after that. I have 4 examples, and what you'll want to do is to pause this video. You want to pause the video, read through these 4 examples, and then identify the most important pieces of each of these problems. So the most important pieces are, number 1, is this a mean or a proportion problem? Number 2, what type tail test do you have? Left tail, right tail, or two tail? Then you want to identify what's your level of significance here. What's your alpha? Alpha is your level of significance. So pause the video, read through those 4 examples, identify those key pieces, and then when you're ready, play the video so you can see if you have identified everything correctly. Now we can identify the most important parts. First problem, this is a mean problem, so that means T everything, students' T distribution. And this is going to be a right tail test. The key word is farther. The coach thought the different grips helped Marco throw farther than 40 yards. So farther means greater than, larger than. So this is a right tail test. There is our value of alpha, 0.1, 10%. Our second problem, it says the average amount of time. So average is a calculation, that's numerical, that's quantitative. So that means this is a mean problem as well. They want to know whether the amount of time played is the same. Is there a difference in the mean? So this is going to be a two-tailed test. Your alpha value, 5%. Third problem. This is a proportion problem, and we know that because it says 15 out of 100. They give you a number out of another number. So that's how you know it's a proportion problem. Test you have to think about. So two types of valves are being tested to determine if one is better than another. So that means one is going to be less than the other, but we got to figure out if this is a left tail test or a right tail test. So 15 out of a random sample of 100, a valve A cracked. They broke under that pressure. Valve B, 6 out of 100 cracked. And we want to know if valve B has a better pressure tolerance. Does it not break as often? So we want to know if valve A cracks more than valve B. So that's going to be A is greater than B. Looking at our first problem, this is a mean problem. So that means we're using the student's t distribution. And what we find is that we want to know the coach thought the different grip helped Marco throw farther than 40 yards. So no matter what technology you're using, it's always a good idea to draw a picture. So we have the shape of our distribution. We know our shape is approximately normal. That's going to be our assumption. Then, since it's a right tail test, that means we're going to shade on the right hand side. Alpha is 10%. So that means this part that's in red is 10% of your data, which means on the other side, it's 90% of your data. So if you're a calculator person, you're pressing second, then vars, then you're going down to the 3 steps, and that's when you're getting to the inverse t. So if you do not have the inverse t function, then there were 2 options that I showed you earlier. So you can use a website to figure out the t value, or you can download the program onto your calculator. So if you have the inverse t function, inverse t takes the area that's on the left. Since this is a right tail problem, you have to find the complement. So you have to do 1 minus whatever alpha is, comma, your degrees of freedom. And your degrees of freedom is your sample size minus 1. Here, they threw for 20 throws, so 20 minus 1, that's where our 19 comes from. So our symbol is T sub alpha. Your T is positive because you're on the right side of your graph. Here, your T scores are positive, and that value is 1.33. If you are a StatCrunch person, you clicked on Stat, you went to Calculators, you went to the T calculator. DF, your degrees of freedom. Since we're looking for farther than 40 yards, you wanted to select greater than or equal to. And then in the very last box, the probability box, you plug in the area alpha that's on the right hand side. Looking at problem number 2. In this example, first thing we want to do is to determine whether we have a mean or a proportion. We know that this is a proportion problem because they tell us a number out of another number. Here we have 15 out of a random sample of 100, 6 out of a random sample of 100. So we know it's a proportion problem. That means we're working with the normal distribution. If you're a calculator person, you're pressing second and vars to go to distributions. You're going to go down to in order to get to inverse norm. If you're a StatCrunch person, you're going under stat and calculators and normal. Next, we need to figure out what type tail test this is. So there is no particular wording here we're used to. All it says is test at a 5% level of significance whether valve V has a better pressure tolerance. So what does better mean in this case? So you need to go back and look at the numbers. So for valve A, 15 out of 100 cracked. And I'm assuming that cracking is not a good thing. And then 6 out of a random sample of 100 cracked for valve B. So valve B, they already have a smaller proportional value that's cracked. So if we're testing whether one is better than another, we're looking to see if valve A cracks more often than valve B. So this is going to be a right-tailed test. So in inverse norm, you plug in the area to the left. Your alpha value is what's on the right. So 5% of our data is on the right hand side. We had to take the complement of that 1 minus 5% to get the area that's on the left. Then we plug in our mean and our standard deviation of 0 and 1, and our z-score is 1.645, rounding to 3 decimal places. And this is a very common situation that we are finding the z-score of. Then you also have for StatCrunch, your mean is 0, your standard deviation is 1, right-tailed test, so we have greater than or equal to, and there is in the very last box where you put your alpha, 0.05. Your critical value is positive because you're on the right side of the graph. Looking at number 3. We read the problem, we figure out if this is a mean or a proportion. They start off by talking about the average time, so that's a mean problem. That automatically tells us we're using the student's t distribution, so we're going to be finding a t-score. And they are looking at boys and girls, so you know you have two samples here. You have their sample sizes, the average number of hours playing sports per day, and your sample standard deviation. We're asked, is there a difference in the mean? So that tells us this is a two-tailed test. Your keywords to know if it's a two-tailed test: difference, changed, has the value, differs. So you're going to end up having two critical values. You're going to have the negative one for the left-hand side of your graph and the positive one for the right side of your graph. If you are a calculator person, we're under second and vars. That takes us to distributions. You scroll down 3 times to inverse t. And then you need to type in what is the area on the left. So for two-tailed tests, alpha is split over both sides. So alpha is the combination of these two sides together. Inverse t only takes your area that's on the left-hand side. So you have to take your value of alpha and divide that by 2. Then you have your degrees of freedom. When you have two samples, you take the smaller degrees of freedom and you subtract 1. So 9 minus 1 gives us 8. Your calculator gives you the negative z-score, but you know that this distribution is symmetric, so your other z-score is going to be the positive value. So you can see it written as plus or minus this value, and you're also going to have, depending on how your problem is set up, plus or minus over here as well. Or they can have you write your answer in two separate terms. So you can have your negative t sub alpha, that's a negative 2.31. You have your positive t sub alpha, that's a positive 2.31. If you're a StatCrunch person, you're under stat, calculators in t, you now click on the between tab because you're working with a two-tailed test. And this, you plug in your degrees of freedom, once again, smallest sample size minus 1. And in the very last box, the area box, you have to plug in your level of confidence. Your level of confidence is what is the area that's in between. You're on the between tab, so you have to tell this calculator what is the area that's in between. Alpha is what's on the outsides of this function. So we take the complement. The complement of alpha is your level of confidence, the area that's in the center. And there are your two critical values. Last but not least, is this a mean or a proportion? It's a proportion. You have a percentage here. A teacher believes that 85% of the students in the class want to go on the field trip. Since this is a proportion problem, that automatically lets you know you're working with the standard normal distribution in your calculator, second vars, inverse norm, and StatCrunch, stat calculators normal. And you need to know what type tailed test this is. She performs a hypothesis test to determine if the percentage is less than 85%. So less than means a left-tailed test. In inverse norm, you plug in your area on the left, that's alpha, 1%, and your mean is 0, your standard deviation is 1. So your critical value, negative 2.33. If you're a StatCrunch person, mean is 0, standard deviation is 1, your inequality sign is less than or equal to, and you plug in alpha into the very last box. So in conclusion, your critical value is found either with inverse norm if it's a proportion problem, or stack calculator's norm if you're a stack crunch person. So proportions, it's always the normal distribution. Your symbol is going to have z sub alpha somewhere in it. For mean problems, you're working with the student's t distribution. So in your calculator, inverse t takes the area to the left in degrees of freedom. In stack crunch, it's stack calculators in t. You have to tell your software, whether it's the calculator or whether it's Stack Crunch, what side of the graph should alpha be on. With your calculator, you do that by indicating what's the area on the left. So left tail problems, you plug in alpha exactly as it is. Right tail problems, you calculate what the area on the left is by using the complement. Two tail problems, you take alpha and you divide that value by 2. And you're going to have two critical values, a positive one and a negative one. In Stack Crunch, if it's a left-tailed or right-tailed test, you change your inequality signs on the standard tab. If it's a two-tailed test, you switch over to the between tab, and then you enter the complement of your level of significance. You enter in 1 minus alpha into that very last box. Hope this video helps.